Hello everyone and welcome to another devlog video for Dwarvernport. I know it's been almost 6 months since the last one. Sorry about that, life kinda just happened. We've got a lot of stuff to cover here. So I'm going to start with the world generation. I overhauled how the world generation happens. So instead of a bunch of if-else statements for handling the different biomes, I can just kind of define the tile type in a dataset. So it pick the UVs that it wants to use, it grab the region the tile is in, set up its navigation, all that jazzy stuff. And what I can do now is I can go to the global class that's accessible everywhere, and I can set up specific tile information. So like, how does this tile react in these biomes? What UVs does it use in each biome? So this is the grass. So for example, we can say in the plains biome, we use these two grass tiles. In a savanna biome, we use these two. In a tundra, we use these two. And then in the desert, we go back to the savanna one. And I can define if that tile is blocked by default and how much it costs to navigate that tile. Yes, I have re-implemented pathfinding. No, I'm not using the built-in navmesh stuff included in Godot. I figured because I already have a tile map with flags of what's movable and what isn't, I might as well just use that. Made a change to water. So in the normal biomes, water is registered obviously as water. In the tundra biome, because I want it to be frozen, it will be registered as land. Later on I'll implement like ice melting and all that good stuff. So like, just like before, we tell it to use these two water tiles in the normal biomes. In a tundra biome, it uses ice. And then you got the same setup for sand, and currently the unused dirt. There's this very similar thing for the biome prefabs that get spawned. So I define the biomes themselves. So let's take the plains. For example, the bush prefabs that it could have are, we currently just have one. So we say it's the bush prefab, and we want to block the tile that it spawns on. And what I can do is I can add multiple of these. So I could say we want a new one. So then we have these three biomes. So when it goes to spawn a bush, it could be any one of these three. The same goes for the trees. And something neat that I can do about this is later on, when I get to spawning passive mobs, I can do passive mobs and then just start defining what they do. And then I can take this information and I can pass it along to a mob spawner, for example. I just put null for default. But yeah, that's kind of the overhaul. It's made customizing the biomes a lot easier, a lot nicer, giving me a lot more control over it. It also cleaned up the code absolute tons, so I can keep track of what's going on. Let's see. I also remade the build menu. So we have our grid container. I added a scroll view, so so the items will spawn in here. This little box, little scroll view. If there's a lot in it, that'll work as you would expect. For this demo, I have made the build menu have 50 items. Yeah, here we are. But then I can actually have the actual buttons here. I've just counted it out for demo's sake. What happens is when you click these buttons, it will just select the building and you can just place it down. I'll show that in a little bit. Wait for buildable data. So what it will do is when this thing is started, it will wait for all the buildable buttons and the data to be accessible on the global class. Otherwise we just process the frame. Here I'm currently doing some debugging with moving the window around. It's not ready yet. It's not functioning like I want it to. Let's just run this thing. So here I've put the clock back in. It's spinning, it's synchronized with the time of day. There's a little day counter beneath it. You notice this little guy is actually walking around now. His AI is not perfect by any means. He still walks through the trees, he walks on water. Currently, because he's listed as, I believe, an air entity, which can just freely move anywhere. This is just while I debug everything, because this is the nav mesh. This is the free space, this is the block space. It's gotten a little bit reversed. I haven't finished it yet. Still a very, very early work in progress. And I can open the build menu, and I can place objects down to be built. Here's the scrolling mechanic of that. It works quite nicely. Still can't move the window on the Godot version. Not much of a problem, and we can close that window. This little guy, he now uses state machine and behavior trees. So if I'm just going to close this. If I go to my little colonist, and here he is. I do not have a behavior tree assigned there. I'm currently experimenting with passing data to the behavior tree itself, but by default it will just run. It's using Limbo AI, the Limbo AI asset, so you can get that by going to the asset lib and then just typing in Limbo AI. I'm using this one, so you can click on it, it'll bring up the window and just hit download. Just ignore the errors that initially pop up, that's just it importing. And yeah, that's what I'm using. So what I've done is, if I go back here, is I've created a little behavior tree on this guy. Very simple. He waits to roam. For demo purposes, I've made him wait 1 to 5 seconds. It'll be more like 5 to 10, 5 to 15 maybe. And I've made an action where he roams. This takes in the component that's used for moving and the range that we wanted to move, so that's 10 tiles. I made a behavior tree action extension class that just lets me turn debugging on and off for the logs, and it also tells me where the print came from. And then after that's successful, it says it roamed. So if we come into the action class, I have the node, the range, the component, the final radius, whether or not it got the path. I set up my movement component and I plug it into my Pathfinder, which is multi-threaded, which is really nice. I calculate the radius and I call roam. So this will get a random point around in the radius that we define, and then it'll try and pathfind to that point. If there's no component, it's a failure. If it's not got the path yet, it's still running. If the path size is more than 0, it's successful. If it's not found, it's a failure. And then this is what's called at the end of the path calculation. Again, this is running on a different thread, so I had to use a signal here. I could go into the movement component. I've made a whole bunch of things here. It's not finished yet, so I've got updating the Z index, the actual moving code. So this is moving along the path. This tries to pathfind. Moving to a specific target, this will be used for monsters in the future, and a roaming function for grabbing a random spot. And then we have a checker for if that tile is walkable with the different traversal types. So land, we check for a land region. Is it blocked? Water, is that blocked? Or air just checks for is this tile any of these two regions? To be honest, I don't think I really need to check. I could just return true, but it could come in handy in the future. If I go into my pathfinding class, I have my signal for the path is ready. The traversal type, what kind of movement we want. So do we want to go forward, back, left and right in like a plus? Do we want to go only diagonally? Or do we want to be able to move in every direction? I set up the grid width and height. To be honest, I'm very tempted to make a global variable for this. Haven't quite decided, so I've just left it dynamic for now. I was working on drawing the path, and it does work, but it kind of just follows the guy along. And, like, I haven't fixed that yet, so I've just disabled it. The thread for the pathfinding, if the thread's currently working, we have to convert to isometric coordinates, because right now, if I whip up paint, right now it's working on a grid basis like this. So it goes, let's say there's a block here, here, and here. It will go, so we can go here, here, and here. And it does move along, but we have to remember that we are on an isometric perspective. So we're more like this, visually. And if you were to take this, and we want to layer that on top of that, you can kind of see how it doesn't really line up properly. And yeah, I haven't really finished doing that yet. Because there's a lot of prints in here, I've got just a debug print function, so I can turn it off. As you'd expect, create a new thread, start it, pass in the variables. Call on thread complete. When that happens, we emit the signal to the path ready, we pass in the path, and we can tell it to draw. Then we have the actual A-star pathfinding algorithm. I'm not going to go too much into it because I've done pathfinding before, and the algorithm is just really freely available online. The different directions. It's very close to my original implementation on the C++ version. This video is already long enough as it is. I'll be here forever if I have to explain this. And I believe I've gone through this already, the actual blueprint, the behavior tree. I'm so sorry, it is 20 to midnight. And yeah, that's pretty much everything. I've only been back at this for maybe about a week tops. Yeah, not even that, 3 days. And that's not that long, but this is what I've managed to achieve in the last 3 days. And yeah, I hope you all enjoyed the video. I'm not very good at explaining things, so I'm sorry on that part. But if you like the game, leave a comment, give some feedback, give me some ideas, and subscribe. Yeah, I'll see you guys in the next one.